Hi guys, good morning. Today we're going to be talking about compound probability again, but today we're going to be talking about compound probability using an or statement. So what's the probability of this or this happening? And the interesting piece of this is talking about how events can be overlapping, how there can be outcomes that can be true for both. And so looking at what that does to the probability. So please make sure you watch the video today and pause it if you want to try to work any of the questions yourself. Email me if you have questions as you're going, and just let me know if there's things that you need help with, okay? So we're going to start with a review question from last week. This is something that people often struggle with, so I wanted to point this out a little bit. So this says a pair of standard dice are rolled one time. What's the probability that a sum of 5 is rolled? So if you look at this chart, okay, let's say the first die is red. Okay, so this would mean a red 1, 2, 3, 4, 5, or 6 was rolled. Okay, now here, let's say this was the green dice, and that's a green 1, 2, 3, 4, 5, or 6 was rolled. The question says, what's the probability that a sum of 5 is rolled? So we're not looking for just what's the actual numbers on the dice, we're looking for what's the sum. And this little chart over here lays it out nicely. We know we're going to have 6 possibilities in each. So we're going to have 36 total possible outcomes, okay? But what we need to do is we need to know which of those possible outcomes have a sum of 5, okay? So this chart lays this out. This would be if we rolled a 1 and a 1, we would have a sum of 2. If we rolled a 2 and a 1, we'd have a sum of 3. That can happen 2 different ways. To have a sum of 4 could happen 3 different ways, okay? To have a sum of 5, which is what we care about, can happen 1, 2, 3, 4 different ways, okay? So what that means then is we have 4 possible ways of getting a sum of 5 out of 36 total possibilities. Dividing those both by 4 to simplify your fraction, okay, you end up with 1/9 of the time, you end up with a sum of 5, okay? So for those of you that like to play dice games or things like that, getting a sum of 5 is fairly likely. Getting a sum of 7 is even more likely, okay? Getting a sum of 9 is equally likely as getting a sum of 5. If you look, there are 4 9s on here. Okay, not sure if any of you play Settlers of Catan. That's a popular game in my household. 5s and 9s are often rolled, okay? Numbers like 2 and 12 are not often rolled, okay? In terms of a sum, it's not very likely, okay? So this is a really common question that students struggle with because it's looking at sums. So this is, I just wanted to show this as a quick way to be able to do that. Okay, let's see if we can get this to focus back. All right, so thinking about last week, what we worked on last week was, one of the things was tree diagrams and counting principle. So from this, find the number of possible outcomes for each situation. One die is rolled, and 1 card is chosen from a 52 card deck. What we would have talked about last week was if this was the die, there are 6 possible options, okay? And if this is the deck of cards, okay, there are 52 possible options there, right? So to find the total number of possible options, you're going to multiply. And you guys can go ahead and pull up your Desmos calculator to do this. I've got my PowerPoint on my screen, so I'm not doing that right now. 12, 1, 31. So there are 312 possible combinations of die and card that you can pull, okay? So looking back again to something we did last week, we talked about compound probability using an and, okay? So this was looking for the probability that something and something else also happens. So a box contains 3 red marbles, 6 blue marbles, and 1 white marble. The marbles are selected at random, one at a time, but they're not replaced. So thinking about this, this would be an example of dependent events. Okay, this was a phrase we used last week. Some of us did the Canvas activity last week. I'm not sure we actually watched the video because of our scores. So if you know that was you, I would encourage you to go back. You have 3 tries at it. I'd encourage you to go back and watch the video. This is dependent because the marbles are not being replaced. That means whatever happens the first time, okay, impacts what happens the next time you pull a marble. So if I'm looking for the probability that I get a blue marble and another blue marble, okay, the first time I have a 6 out of 3 and 6 is 9, and 1 is 10. 6 out of 10 chance of getting blue, okay? The next time though, if I've already pulled a blue, I only have a 5 out of 9 chance of getting blue, okay? This decreased because there's one less marble, and this decreased assuming that I pulled a blue from that first one there, okay? So this would give us here, canceling there, we've got a 2, canceling there, we've got a 3. This would give us a 1/3 chance of that happening, okay? Now, this would be independent if the marbles were replaced, okay? So today we're going to talk about a little bit more about some special kinds of events that have relationships. They're not necessarily dependent on each other, but they are connected, kind of like dependent events are. So today what we're going to do is we're going to work on finding the probability of or statements, okay? So the probability of this or this happening. Last week we worked here. Today we're focused on the or statements. As a reminder, you have your Desmos calculator. You are welcome to do the fraction work on there. That's fine. I can trust that you can all do that at this point. This button over here, though, is going to be really helpful to you. Beside your ugly decimal answer, okay, you want to click that. That's going to turn your answer into a fraction, okay? And it's okay. It'll keep it as a reduced fraction also. So let's start with a fairly simple one. You're rolling a 6-sided die. What's the probability that you will roll a 2 or a 5? Well, when I think about what this would mean the probability of 2 or a 5. I know that I have, if I roll a 2, there's only one way I can win. And if I want to get a 5, there's also only one way I can win. But if I'm okay with getting a 2 or a 5, there's going to be 2 out of 6 possibilities that would make me a winner, okay? Or in other words, 1/3 or 33%, okay? Now, if we think about what we actually did here, we took these two probabilities and we added them together. The probability of getting a 2 was 1/6. The probability of getting a 5 was 1/6. Added them together to get 2/6. Okay, so that's kind of the initial understanding with or probability. Okay, to find the probability of compound events that include an or statement. Okay, basically what you're doing instead of like and where you multiplied, or is all about addition. Okay, the trick with this though is looking at, do the events, are the events connected to each other in any way? Or another way to maybe say that is there any overlap between the outcomes in the first event to the outcomes in the second event? Okay, so we'll go through some examples like that in just a minute here. So probability with an or statement. It says a drawer contains 3 red paper clips, 4 green paper clips, and 5 blue paper clips. 1 paper clip is taken from the drawer. What's the probability that it's red or green? Well, when I read this, I know red and green don't share anything, okay? So what I can do here is if I'm looking for the probability that it's red or green, I'm going to short form here. Basically what I'm going to do is I'm going to add the probability that it's red to the probability that it's green. So the probability that it's red, I've got 7, 12 in total, is 3 out of 12. And the probability that it's green is 4 out of 12. That means the probability that it's red or green is simply 7 out of 12. Those added together, okay? These spinners should look familiar. These were ones that we used last week. Using the 2 spinners, find the probability, the compound probability, because this is happening for more than one event, that you get an A or you get a 2. So what that means I'm doing here is I'm adding together my probability of an A and my probability of a 2. So my A has a 1 out of 4 chance of happening. My 2, there's 2 of them out of 6, plus 2 out of 6. So now this just goes back to your fractions, and you can go ahead and do this on Desmos. That's just fine. Okay, you can make them both 12s here. Okay, it's going to be a 3. That's going to be a 4. Adding them together. Okay, you end up with 7 12s. Okay, so thinking about what we're doing here, right? The compound probability, if the events are totally separate and don't share anything, you just add their probabilities together. Okay, let's take a look at this one here. It says you spin the spinner once. What's the probability that it's a 3 or that it's odd? Well, this starts to get a little bit messier, because what happens here, that 3 isn't exclusive of being odd. Exclusive meaning separate. Okay. If I think about the things, all right, that would give me a 3, all right, a 3 obviously is that, but my odd numbers are a 3 and a 5. So that 3 is actually a shared number right here. Okay. What that means that we have to notice here, because the 3 fits in both of these conditions, okay, we can add the probability of the 3 plus the probability that the number is odd on here. But we have to then take away the probability that it's 3 and that it's odd. Okay. Now that seems kind of funny, but let's kind of talk through this a little bit. If I want to know the chance that I spin this and I get a 3 or I get an odd number, well, the chance that I get a 3 is 1 out of 4. Okay, that's the probability that I get a 3 is 1 out of 4. Okay. And the probability that I get an odd number is 2 out of 4. But if I think about that, if I would add that together here, that would say 3/4 of the time I get a 3 or an odd number. What I've done is I've counted that 3 twice. Okay, that's not what you want to do here, right? You need to say to yourself, okay, I'm going to count that 3. That's one way I can be successful. But if I think about what this says, trying to have this thing focus, I'm sorry, guys. If I want to know the probability that it's a 3 or that it's odd, I would win if it's a 3 and I would win if it's a 5, but I can't count this 3 twice. So what this ends up being here is that's 1/4, that's 2/4, but then I actually have to take away this double counted 3, okay? So sometimes we can do this in our heads. We can say, oh, that 3 would be twice, so I'm just going to get rid of that and end up with the 2/4. They cancel each other out, okay? So what you're looking for here, this answer here would be 1/2, okay? What you need to look for here is, do these two events, okay, share any outcomes, okay? So let's try this one here. A card is randomly selected from a deck of 52 cards. What's the probability that it's a 10 or a face card? Okay, well, the probability that it's a 10, all right, there are 1, 2, 3, 4 of them here. Okay, do any of those have a face on them? No. So that means these are totally separate events. Okay, the probability that it's a 10 is 4 out of 52. And the probability that's a face card is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 out of 52. That means we have a 16 out of 52, okay, or 8 out of 26, okay, divided by 2 again, or 4 out of 13 chance of being successful here, okay? But if this question didn't say this, okay, what if the question said, what's the probability that you get a queen or a face card? Okay, so I'm going to use a different color here. The queens are right here. 1, 2, 3, 4. So there's 4 of them again. So we've got 4 out of 52. But then if I go to count my face cards, I'm not going to go 1, 2, 3. I don't count that queen again. Okay, I can say, okay, there's 12 of them here. Okay, but there's also 4 that I'm going to double count. So in this case here, it would make sense just to add the 8 52s. Okay, there's 8 of these. So then we would end up with 12 52s. Okay, dividing them both by 4, you end up with 3 13s. Okay, this is a much trickier idea than what you worked on last week. So I want you to make sure if you're not understanding, you're reaching out. Okay, let's look at this. It says, what's the probability that it's a 2 or that it's even? Okay, So what we have to decide first is, are these separate events, 2 or even, or are they going to share some of the things? Well, I know 2 is an even number. So what that means then is that these are not mutually exclusive. Okay. There's going to be some overlap, so I'm going to have to take some of this away. So the probability that I get a 2 is 1 out of 6. The probability that I get an even number is 3 out of 6. But the probability that I get a 2 and an even number, which by definition has to happen, 2 is even, is 1/6. So I'm going to add those two together, but I'm going to take away my overlap. Okay, I'm going to take away the one that's true for both. So adding these together here, all right, I'm going to end up just with 1/2. Okay, 3/6 or 1/2. So the trick that you have to think about today is, are the events totally separate, or are there some outcomes that are true for both events? And if that's the case, you can only count them one time. So your work today, all right, there's kind of a couple different things I want you to do. The first thing I want you to do is, on 7th grade IXL, I want you to practice DD3, okay? It should be questions like what we've done today, all right? So this will be questions like the mutually exclusive probability and the overlapping events that we've been working on, okay? After you've gotten that score, let's say we get up to about 80, okay? Then what I want you to do is, I want you to go back to Canvas, and I want you to do the exit ticket that's linked in the Canvas post, okay? Only do this exit ticket after you've done some practice, okay? If you're working and you're getting a bunch wrong, it doesn't make any sense to go do the exit ticket and get them all wrong there, okay? Try to get up to 80, all right? If you get stuck somewhere, send me an email. We can try to work through the question together, okay? But then I want you to go back to the exit ticket once you've got a little bit more of a better understanding, okay? This is tricky, guys, and that's okay, all right? So please make sure you're getting those things done. Also, as a reminder, your assignment from April 13th is due today. This was the first assignment about probability. It's fairly basic. It's on Canvas. Please make sure you get that done. You can check Skyward to see if you are done or not. Okay. So I hope you're all doing well, and reach out if you have any questions or concerns. I hope this wasn't too confusing. This is a hard topic to try to teach without being there with you guys. So I miss you guys and hope you're doing well.